Okay. Do you want to start right now or
Yeah.
okay.
Yeah, sure.
Okay. So hello, welcome to the A08 final exam review seminar. Me and Katrina are going to be walking through some of the content that was near your final exam, so you know all of that stuff. So let's get started. So we're going to be covering the generating a new story exercise. And then unit testing, and then we'll go over some of the sorting algorithms. So selection sort, insertion sort, and bubble sort. So let's get right into it. So generating a new story. So we need the concept of a dictionary. So let's just go quickly over the dictionary type in Python. So the dictionary type stores values in key value pairs. And the keys cannot be mutable, so they cannot be changed. So you cannot change a key once it's in the dictionary, so it can't be anything that can be changed. So for example, it can be a string, but it can't be a list or another dictionary because that's mutable. So that can be changed. So that's not good. So we want it to be something that cannot be changed. And anything can be stored as the values. So both immutable and non-immutable things can be stored as values. So you can store lists as values or other dictionaries. And remember, it has to be these kind of braces, not the sharp edges one or the round ones. It has to be the curly braces. Okay. Is everyone clear on that? Does everyone remember how dictionaries work? Okay. So here's some examples of dictionaries. So first of all, we have epic people. So Alex. So this is a dictionary that has the names of people as the keys. And remember, these are strings, so they cannot be muted. So that's important. And it stores a list of their majors. So for me, it would be math and CS, and for Katrina, it's stats and psych, and then AMAC covers math, stats, and CS courses. We also have cool profs. So Anya for it has strings as the keys. And remember, strings are not mutable. So I just want to drill that home again, just so everyone understands that. So the strings are not mutable. It needs to be something non-mutable. So we have names of profs and their the codes of the courses they teach. And then finally pair to pair, which has remember that's a tuple, and tuples are like lists, but they're not mutable, so you cannot change them. And it maps a tuple to a string. And we're allowed a tuple because remember, tuples cannot be modified. Okay, and here's some useful dictionary methods useful dictionary methods to remember. So get will give you the key specified at a given key value. So if I do, for example, if I have a dictionary epic people and I do .get Alex, well, if we go back here, so we have the epic people dictionary and we have Alex. So if I go back, if I call get on that, that will give me the math and CS list, because remember, the value at Alex is this list. Oh, sorry. The values returns a list of all the values in the dictionary. So for example, if you do for value and cool prof stuff values, and so this is a for loop and I'll loop through all the values. The values will be, so for example, if you have, for example, let's go look at the cool profs again. So cool profs, we have Anya and Anna and Natalia, and we have their course codes right here. So what values will do is give you a list of all those values. So right here we have CSCA08, CSCA67, MAT A31. So what this does is just gives us a list of all the all those values. So not the keys, it's the values. And then what we loop through them here. Okay, so generating a new story, designing our program. Yeah. So dot keys would also be like the analogous one, but for the keys. That will give you a list of the keys. So for generating a new story, so for designing our new program, we want a program that looks through a text file and uses a certain number of words as the context and generates a new story randomly using a new context. So for an example of a story, we have Alex and Katrina are cool, Alex and Katrina are awesome. So the context is defined as the words that come after a two-word pair, but you can make the context as big or small as you want. So you can have a context of one word or two words or however many words, but for this example, we'll use two. So the context is given by a tuple, and then it's just a list of all the words that would come after that. So we have Alex and then Katrina, because Katrina's the only one that comes after that pair, and so on. And we have Katrina R and then cool and awesome because both cool and awesome comes after Katrina R, and then R cool and cool Alex. So it's just a list of all of the words that come after a given word pair in our current string, and then we use this to randomly generate a story. So each time the program will go through a list of words after the current context, print a word, and then create a new context from the last word of the previous context and the new word chosen. So you go through the list of words, and then after a current context, you print the word, and then you create the new context from the last word in the context, and you put on the new one, and you get rid of the first one. So if the current context is Katrina R, and we pick cool in here randomly, then the next context becomes R cool. And we keep doing this and doing this and doing this randomly. And for storing the context, we use the dictionary of tuples that maps to straight a list of strings. And this is the best data type for the implementation because the tuple data size will allow for the context keys of any size. So we want this, right? We want our context to be size 1 or size 2 or size 3. But the problem is we can't use lists because remember, lists are mutable and keys cannot be mutable. They need to be unmutable. So this is the best data type to use because we can have context keys of any size and they're not mutable, so they're allowed to be keys. And we store each word in the file in the list. So when we initially go through the file, because that's what our program is going to do initially, we'll go through the file and we'll read through it, and then we'll store each of the words in the list. And this gives us an easy way to see what word comes after each, so we can create the initial context. And you can make such a list really easily using the split function. Python has a really nice string manipulation, unlike another certain language that we won't mention right now. Yeah, but we can make a list easily using split. So just remember, you can split a string into, or you can split like a string into like a bunch of just tinier strings. Yeah. We can split a string into a bunch of tinier strings just using the split on the, so remember we have a file name, then we call read on it, and then we call split in it, because read will make it into a string, and then we split the string. Split by default splits along spaces, so that's what we want. Does anyone have any questions on that, or is that clear? Okay, next slide. Yeah, so generating new stories, so read words. So read words, we'll just go through our file as we discussed. It will return a list of words in the order they appear in the file. And we're assuming that this file is already open for reading, meaning don't reopen or close the file from the function. This function is assuming that the file is already open for reading. So we don't assume that, where we don't like open the file again or close the file again inside of the read words function. We assume that the person using the function is already responsible for that. Yeah. And then the read will just return a string of the entire contents of the file. And split will just return the list of strings that's broken up over that string over the spaces. So does anyone have any questions about that, or is that clear? Okay. All right, so now we can do build context to words. So we have a context to words dictionary, then we go through our word list, right? The word list we created from the last function, and we create a context. So the context would be, remember, a word list, a tuple of a word list I to I plus 1 of context size. So we would have we'd have I to I plus 1 of context size, right? And we're mapping, so we're creating we're basically making our list into a tuple. So we're going through our list of words, and we're going to go from the I spot to the context size spot, and that will be chunked off into its own context. And then we have the word in the word list that comes after the context, and that will be the word that comes after it. So remember, just to review for going back for our context, 1 second. We have a tuple, and then we have a list of words that comes after it. So that essentially does what we want to do. So we create a new context of the words that come before it, and then we have a list of the words to come after. And if the context is already in the list, then we'll just append to that context. Remember, in dictionaries, we can access the key to append. Else we create a new place in the dictionary of that key, which is the context, and we put the word in there. And we just walk through the whole word list and do this process. So we chunk off the context size of words, and we make that the key. And if that key is already in the dictionary, just depend on the word that comes after. Otherwise, create a new key for that. And that's how we'll just build the context. And finally, we have the generate story program. But now that we've built everything, it's actually not that complicated. So we have just the story string, and this is just empty. And then you grab a random context from context to words. So remember, we built this in the last function. And then in the range, in the number of words we want our story to have, which is just defined when we call the function. So we'll grab words. So this is a specific this is the word, one of the words in context words. We grab the list first, and then we make a random choice of those words. And after, we will make the context to be the one we chose plus the last one of the. So yeah, so we just append the word we chose onto the last context, and we take off the first one from the context. And that's how we get to a new context. And we keep doing this until we've built a story that we want. So until we've built a story as long as words long as we want. And that's basically the idea. That's how you would do the generate a story program. Yeah, so we would build context to words, blah, 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 and yeah, so yeah, generate random story. Did I skip past that? Generate story, I guess we just call generate random story. This is just the function that wraps everything together. We would have the read words that gets the word list. Then we have the build context to words, which takes in this, which we've built from the file, and then builds the context to words dictionary. And then we call generate story, which we built from the last slide. But this is just the function that wraps it all together. So that wraps all the stuff we've built together into one cohesive program. And that's the main idea. That's how you do the generate a random story program using dictionaries. Does anybody have any questions about that, or is that clear? Okay. So
Okay. Yeah, I can share my screen if you want.
yeah, it might be easier.
Yeah, let us know if we're going too fast. I know I have a habit sometimes of going too fast. So yeah, just let me know. Honestly, any questions are welcome. We're here for you guys. So yeah, let us know if you have any questions. All right,
I'll keep an
so
eye on the chat.
Thank you. Unit testing. Unit testing, you have a small brief period where you talk about this in A08. In a further course called B07, as Alex knows, we go a lot more in depth with unit testing in Java, another language we'll go through. And yeah, we don't touch on it in C in A48. But in Python, there are two different types. So there are functions that have return values. These ones actually create, or they allocate new space, and then they copy over the information, the new information. And here's an example down below, like return list. So if we have coolest, we create a new list, an empty list. And then for each one in the cool list, we copy it over to new list. And let's say like our functionality for this, we wanted to add one to each object in cool list and then create a new list. And then we return this. But the second type of unit testing that we have, so this is just the examples, but our function, let's say it actually mutates the list given. So we have an example down here. We have modify list, where look at the return type. We do not return anything. So this one is actually modifying the list given. And that'll be more important for the language C, but just to remember, there are two different ways. So we're gonna go over the length of coolest, and we're gonna find the index. And at the index, we're gonna just add one. And we're actually mutating coolest, which means that if you call coolest later, it will be mutated. Not like this other one where coolest won't be touched. Okay, so this is kind of the format of how we test in Python. So we create a class. You don't really have to know what a class is for this course. For the sake of this course though, you define functions within this class. And this is the testing functionality that you do need to know. So from here, this one's testing the return list. We say what is actually returned, so what you're actually testing for, and then you want to give an example that you know the expected value that you want. So in this case, we know that we're adding one to each of the values inside the list. So our expected is going to be 2, 3, 4. And our message, message is it's a separate function that's already been coded. You don't have to worry about that. But we want return list, and so the function we're calling, what parameters we're passing through, and then actual and expected compared. And then last but not least, we actually call, I think this is an imported list, and it gives us a couple extra functionalities or built-in functions that we can test. So we compare actual to expected. If they're equal, great, it doesn't display the message. But if something goes wrong, then message will display. Yeah, if anybody has any questions, let me know. This is for the non-mutating list. So this non-mutating example is for return list. It'll actually return a new one. I think it would be smart to, I think you should memorize it because you should be expected to know the functions. For the third example, or second example, sorry, we have another one. Sorry, this should say test modify list. So we're gonna have the actual, we modify it, and this will, you can tell that this, we don't actually set it equal to actual. Because if we actually did set it equal to actual, it would end up just being null. It would be none. Because remember, the return value of modify list is none. It's not, it's modifying the actual list. That's why we want to set it and then we want to modify it. We know the expected again, it's the same one. Yeah. We set the message, make sure it's modify list this time, and then we compare again. Kind of the same as last time. Yeah. Okay. All right, so does anybody have any questions about unit testing? It's kind of a small unit, I know that. For them, I think you are expected to know how to write this format. So maybe not the class, but the function itself, yes, you should be able to. On an exam, if they ask you this question, they would tell you specifically if message is already designed. Yeah, we can go over message. So this actual message, it's a separate function that's already encoded. You don't have to encode it. But basically it takes in 3 parameters. It takes in what function you're working with, what the parameter is going inside of it, and then actual is the data, or it's our list here, but what's actually being returned compared to expected. So expected is what we expect the result to be. And we just assign it to this value or this variable called MSG or message. And then when we call this function down below, self.assert equal, we compare actual to expected. And if this is incorrect, if they don't equal each other, then it displays message. Does that help? Yeah, so like Alex is messaging in the chat, there's something called black box versus white box testing. So black box means you don't really need to know what the function message does in the background because you're not really expected to know that. It's quite a simple function. You could code it. It's like return a string of modify list, produced this, but it's supposed to be this. You just return a string and remember the concatenator, the plus sign in between each of those. For now, you don't need to encode message. It would be like on an exam, it would tell you whether or not you need to encode it. I don't think that would be tested. Yeah, just memorize the syntax for using it. Yeah. I hope that makes sense. Okay, good. Okay. All right. No worries. Okay, so for time complexity, this one's quite cool. I know Alex is going, oh boy. There is only technically like 3 or 4 time complexities that you work with in Python. In your next course, CSCA08, much more in depth. But for now, there's constant time. So constant time means every time you run this function, it's always going to be the same, no matter the input. MP63, yeah, I haven't taken that course. Linear time means that there's one variable inside of here. It's okay if it's multiplied by some constant, but when you're going over linear time, it does change depending on the length of the input or the size of the input. And then quadratic, it's x to the power of 2. Yeah. Or as we like to sometimes say it, like n squared. And then polynomial time, you don't really discuss this one. It's basically like if there's a constant, linear, and quadratic, and it can go into higher powers, but you don't really have to know that for this. Yeah, so I think we'll go over an example here. Yeah, okay. So right here, this one, we're going to say the length of each of these lists is k, just so that we have a constant variable that we can look at. So for this one, for I in range length of L. So this means that this for loop is going to go over all of the different values of L. So the time complexity for this one is going to be k, where the length of L is equal to k. We could say the time complexity is the length of L, but we like to shorten it into a variable so we can do more math with it. Yeah, do thing. It can be whatever implementation you have. There's a next slide, there's going to be an example with several different loops. So if there's like 2 or 3 or 4, but I'll explain that later. So this is a linear runtime where, let's say the length of L is 10. The runtime or the time complexity is going to depend on the length of L. So if the length of L is 10, time complexity is going to be 10 times. If the length of L is 99,000, the time complexity is going to be 99,000. Okay, so it does depend on the length of L. On the contrary, some loops have a constant time. So for this one, you can see the constant is just 3. So regardless of how big our L is, if it's 10, 99,000, it's always going to run only 3 times, which is pretty nice. For every loop, it's k and repeated I times. L times. So it's not L. L is the length, or sorry, L is the list. K is the length of the list. So I guess, yeah, it depends on like what your for loops do. So if we look at, I'm gonna skip a little bit ahead, but let's say we have 2 for loops, right? We would multiply the different amounts of times that it runs over. So in this case, we would have length of L here. So we know that this for loop, the outside for loop, is going to run k times. The inside for loop is going to run k times as well. So we multiply them together and we get k squared. What would this one be called, just out of curiosity? What type of time complexity is this? Yeah, quadratic, exactly. Yeah. For the second one, same sort of thing, but you see the inside one is only 3. So it's always going to run 3 times, no matter the length of it. And then the outside loop is going to be length of L, which is also k. So then we do 3 times k. What's this one called? Yeah, linear time complexity. Awesome. Just back to this one, like a quick one. This last example, if we cut the complexity in half, Alex, correct me if I'm wrong, but for this one, if we are looking at constants multiplied by the by k, we actually disregard it because on a wide enough scale, it's not going to matter.
Yeah, so the idea is that you have these things called complexity classes, and we don't really care about constants. We only care about the actual variables themselves. So that would just be treated as a linear time function. I don't think in this class they care really that much about complexity classes, but so they'd probably just want you to write down k over 2. Can anyone tell me why this is k over 2? So remember what range 0 len L2 does. Yeah, basically. So it basically defines the step as 2. So instead of going 1 each time, you're going 2 steps each time through the list. So we'll cut it in half. Correct.
What if it was, I'm going to type in the chat. What if it was range
I think it's floor k over 2 if you want to be like super pedantic about it, but like it doesn't really matter.
What
It's
about
k
this
over
one in
2.
the chat? Yeah, exactly. Yeah, it should be the same. You can't have it negative. You can't have a negative time complexity. Yeah. Okay. Hopefully this is making sense. And yeah, so these are, you can have like loops inside of loops inside of loops inside of loops. Don't get too scared by those. It just means it's going to be horrible time complexity. So you don't usually see those. You want to optimize it. But yeah, you just want to look at how many times it's looping over in that specific for loop and account that for all of the different for loops. Yeah. So that's everything we have on time complexity. Oh, I think we're doing good for time. Does anybody have any questions about time complexity or unit testing before we go into sorting algorithms? Because these might get a bit more complex. No? Okay. Okay. So we're going to be going through 3 of the main sorting functions over this review seminar. So we've got selection sort here, insertion sort, and bubble sort. Okay. So for selection sort, best case, worst case, there's none. How will time complexity be tested on the exam? They would give you like a function. They'd either give you a function or they give you an algorithm, like for I in range of length L, do something. And then they would ask you, what is the time complexity? Exactly what Alex just said. Yeah. Yeah. For selection sort, I'll go over each one of these in more depth, but in all cases, there's no best or worst case with selection sort. It's going to be quadratic. And the number of comparisons we're going over, if you recall back to A31 or A37, we're going to do this. Yeah, we'll go over that a little bit. Insertion sort, it does have a best case and worst case. We've got linear and quadratic. We've got n squared comparisons, and then bubble sort, kind of same as selection sort. There is no best or worst case. It's always quadratic. Yeah, so let's get into selection sort, okay? So what this does is it has the left side as completely sorted, and we keep going through each of the values in L, sorting it to the left side. So basically, it'll keep searching the unsorted part of the list for the smallest value and then placing it at 0, placing it at position 1, and swapping the values of whatever is there already. So this is the algorithm here. So it doesn't actually change anything. It's mutation, remember from unit testing. And it's going to go from left to right. So for I in range of the length list. So what's the time complexity of this? Just out of curiosity. Yeah, so for this function, it's I in range length list. So that's K. But another thing to note, inside of here, we've got index of smallest equals get index of smallest list of I. So if we look over here, we've got another for loop inside of this for loop, just in 2 separate functions. So this one from here, it's going to be going from I plus 1, I's pass through, and then we go to the length of the list. Yeah, so we find the smallest by doing that. We start with whatever item we're at I, and then we go through the rest of the unsorted list. And I'll show you an example right after this. And we compare it. So we go through the rest of the unsorted list. This is what this loop is doing. And if the list of J, so in the whatever position is in the unsorted list, is less than the list of the index of smallest, the current one, then we're going to replace the index of smallest with wherever J is, saying that we found the smallest one. We keep going through the entire rest of the unsorted list, and then we return the index of the smallest, and then we swap those values. So that's what this code is doing right here. This is a little bit like you might not have seen this notation before. What we could do is we could do like temp equals list of index smallest, and then we would say temp or list I equals temp. Does that make sense to switch it? This is just a shorter format. Oh yeah, we can do that, yeah. Okay, so I'll go through an example. So let's say we have this list here. This is just a random one because it doesn't have best or worst case. So we have 6, 0, 1, 5, and 10. So the first pass we're going to go through, we're going to look through all of the values and we're going to find the smallest value. Remember, that's what this function here, get index of smallest, is looking for. So it finds the index. It's going to be 1, index 1. The value being 0. And we're going to switch it with this 6 here. So that's what we do here. First pass. Second pass, we know 0 is already sorted. So we leave that be. That's why in this get index of smallest, it's I plus 1. So the left side, once we've swapped one value, so in that example, we've already switched 0, the value 0 to the index 0. That's already sorted. We don't deal with that anymore. Now we look from I plus 1. So that's from 1 to the end of the list. We look for this next smallest value. It would actually keep looking. So that's why this is why it's not the most efficient, because this complete section is unsorted. So we never know, like we can see it visually, but the computer doesn't know what's the smallest value until it's gone through the entire unsorted list. So let's say we had like 10,000 values after that 0, we would have to search those 10,000 values and then 9,999 unsorted once we keep switching. That's why this is quite inefficient, and that's why the time complexity for this is k squared. It's quadratic, very slow. Yeah. So yeah, once we find the 1, we switch it with the 6. Same here, we try to look through the unsorted list. We find 5, so we switch that with this position here, I equals 2, which is 6. 6 keeps moving around. 6, that's now the smallest one. And since it's at the same position, we just leave it. And then last but not least, the last value is 10. Does that make sense? Does anybody have any questions? Something's confusing them? I can always go over things. The reason why there's no best and worst case scenario is that we have sorted and we have unsorted, and we don't know where all the values in the unsorted list are, like the smallest index. So we have to go through all of it.
Someone asked how would they be asked about it on like an exam, and I actually don't remember how they tested it.
They might ask, what's the time complexity of this, of selection sort? Or, I'm trying to remember how they would test it. They might ask you to code it. I don't know if they would. They may ask what has the best time complexity, or what's the best and worst case scenario. that will be a tricky question, right? Because if they ask for selection sort, what's the best and worst case time complexity or worst case scenarios? You'd have to say selection sort doesn't have a best or worst case scenario. So just be careful about that. Same as bubble sort. Bubble sort doesn't have a best or worst case scenario. Only insertion sort does. I think, I mean, they might ask you to do this, like they give you a list and say, explain how it switches. Why is selection sort always quadratic? Okay. Yeah, so as we're going through this, let's go back to the function. So this one right here, this first for loop, that's going to be k times. That's going to have k complexity on its own. And then for this one, this last one, get index of smallest. If we look here, this for loop, we have to call that n amount of times because it's going to go through all of the unsorted list. So the first time it's going to go through all the different values. The second time it's going to go through all the unsorted values. And since there's one sorted, that's k minus 1. And then k minus 2, k minus 3, all the way until we get to the very end. Yeah, so what Alex is saying, we have to do k times k. And remember, if we have to sum it up, oh, what is it? The amount of times in calculus. Alex, do you remember? Can you explain it?
Oh, yeah. Let me think. It was like the sum from n equals 1 to k,
this
right?
one, yeah. This is why
Oh,
we
yeah. So the reason why it's n times n over 1 over 2 is because let me try to write this down. It's I equals 1 to n, right?
yeah.
Okay. And then
And
it's
it's I, isn't it?
yes, it's I
Yeah.
is equal to n minus 1.
Actually, I can
2.
draw it too.
Yeah, there's actually a proof of induction of this. It's not too difficult, though I'm not going to assume, I don't know if everyone here has like that kind of math background. So I guess you can just treat it as like a neat math fact and we can black box, but that's like the reason why, because you're going over, you're doing you're doing one comparison, then you're doing two comparisons, then you're doing three comparisons, then you're doing four comparisons, up to k comparisons. So it's yeah, so it's because of that. So if you don't know what the sigma means, it just means sum I from I equals 1 to k.
Yeah. Okay. Thank you for explaining that while I'm painfully drawing this with my
Yeah,
laptop.
no problem.
This is a 2. This is a 2. Um, but yeah, you typed in the chat. This is a proven fact. Since every time that we keep going through all the different comparisons, we do minus 1. So the sorted area, we start at n or k. Oh yeah, sorry, I should, this is gonna be a k or an n. So I'm gonna do this as n because that's what I have written down here. So this is an
Yeah.
n. To keep my variables straight. So if the length of the list is n, we do n amount of comparisons the first pass. Then the first index now is sorted. So then we do n minus 1 comparisons, n minus 2 comparisons, all the way up until we get to 1, which is why we have the summation. Yeah. Does that clear it up? Does that make sense? I'm gonna redraw this.
What does I think so. Yeah, I think what that means is that in every single case in running this function, it's always going to be n times n minus 1 over 2. There's no case that gives you like a better time or case that gives you like a worse time. It's always going to be quadratic. It's guaranteed quadratic.
Yeah. Unfortunately, because you never know in the sorted or the unsorted list where that smallest index is
Yeah.
going to be, or
I
that
think-
smallest value.
I think in like 848, we would just call that the worst case, but in this course, you
Yes.
just say all cases.
Yeah, so for this one, there is no best or worst case because all of this is unsorted to the right. Yeah. Okay, if there's no more questions about selection sort, I'll go into insertion sort, and we'll have, I think we're going to have quite a bit of time at the end. But yeah, we can go over examples, any questions you guys have. So insertion sort, kind of similar, don't get them confused. This one has a much better, like it's still not ideal, but it's a much better time complexity. It's just linear instead of quadratic. So let me just remember how this one works. Yeah, okay. So basically what we'll do is whatever one is right here, whatever position we're looking at, we compare it to everything to the unsorted one. So instead of looking at the unsorted list and then trying to find the smallest one, like in selection sort, for insertion sort, we look at the ith or the I index, and then we compare that value to the rest of the sorted list now. And we figure out where it needs to be placed there because we know in the sorted list, it's sorted. So once we figure out that there's a value that is less than a value that we're looking at, then we want to leave it there. I'll explain this in detail. So here is the coding algorithm. So we have insertion sort for I in range length of list. So that's the first K, or that's the first N, that's the length of list. We're gonna have to go through it at least n amount of times. Insert list at position I, or list and I. So this is another function. A lot of these have helper functions. So right here, we get the value first. So let's say in this example, I is 1. Okay, so the right side is completely unsorted, left side is completely sorted. So value equals list at I, which is 1. While I is greater than 0, so the index is greater than 0, you're not going out of it. And the list at I minus 1 is still bigger than the value. So let's look at this practical example. List at I minus 1 is 6. 6, is that greater than 1? Yes. So this while loop still holds, and we're going to switch it. So list I, which is 1, becomes 6. And then I equals I minus 1. So we look over now. Okay? So now we look again. While I is greater than 0, so I think is this position right here, so it's not. And list I minus 1 is greater than value. So can you see that we set value to be set value? We don't change it yet, because otherwise, if we keep overwriting, we're not looking at list I. So we compare I, which is 1, to 6 again. We move it over again. So we move 6 to be in this position, this 0, 1, 2, 3, this third index. Then we keep going. So then I becomes I minus 1. We compare 1 to 4. We switch those. We compare 1 to 3. We switch those. And now I is not greater than 0, so we can't compare anything else to the left. And then we set list I, which is 0, equal to the value, and we don't return anything. I know that might be a bit confusing without an example, so let's go through it. All right, so insertion sort does have a worst case and best case. Remember that. So this is a worst case example. Let's say the entire thing is completely flipped. Okay, so we need to sort through this. First one, I equals 0. Remember, we're looking at I is greater than 0 in the in here in this while loop for insertion, while I is greater than 0, so we can can compare the value right below. So since we're looking at the first position, I is equal to 0, so it doesn't really matter. Past 2, I equals 1 now. So we're looking at 13. We get the value of 13 and we assign it to list, or we assign it to value. Then, while I is greater than 0, now I is 1, and list I minus 1, which is that 27, is greater than 13, we want to switch them. So list I, which is right here, becomes 27. Now, right now, we have 2 27s in the list. But now that I is equal to 0 again, because we subtracted 1, list I equals the value and it becomes 13. So that's how we get that switch here. Hopefully that's making sense. Same here. So now we know that 13 and 27 are organized, they're sorted. And I have the highlighted, so I'll explain the highlighted part. So when it's yellow, it means that's what it's comparing right now. So it's comparing 11 to 27. 27 is still greater than 11, so we're going to switch it. And then we compare 11 to 13, we switch those two because 13 is still greater. Now we know all of this blue part is sorted. So the blue part is sorted, yellow part is what we're comparing, and no highlighted is unsorted. Maybe I'll write that down for the next time. Yeah, keep walking through each part. Yeah, and then we keep going through 27 and 4, 27's bigger. We keep moving 4 down. And then last one, we have to do that many comparisons. That's why it's a lot bigger. And that's why in this worst case scenario, actually, can anybody guess what's the time complexity for this worst case scenario? Yeah, it's quadratic. Yeah, exactly. And it's because once we get to the end, right, we have to go through all the different values below it. Whereas as soon as this while loop is not true anymore, like as soon as the value's in its right place in the sorted list, then it just stops. So yeah, this is why it's quadratic, but in a best case scenario, what is this instead of quadratic? Linear, exactly. Because we're comparing 1 to 4 or 4 to 1. 1 is less than 4, so that while loop completely stops. And it does it for all of these, and it's only going through the list one time. Whereas the other one, we would go through the list n amount of times for the length of n, which is why it's n squared. Okay. Any questions about insertion sort, or if we're good, I'll move on to bubble sort, the last one. Okay. Okay, so last but not least, we have bubble sort. This one's pretty cool. I like the visuals, so to speak, for this one. So for this one, it's kind of the opposite of selection sort. We're gonna look for the largest values and keep moving them up to the right side this time. So, yeah, it keeps looking for the biggest value. We keep switching it over to the right. And then once we find the biggest one, it's kind of weird to like describe, but yeah, so in this example, we'd have 1, 2, 7. So we'd start with 1, compare it to 2. 2 is the biggest one, so we compare 2 to 7. 7's the biggest one. Since 7 is bigger than 3, then we would change 7 and 3's positions. Compare 7 to 9. 9 is now bigger, so we would leave that. 9 switched with 1, so since 9 is bigger, we would switch that, and then 9 compared to 8, we would switch those two. And then now the right side is the one that's actually sorted. So this is again the implementation. So from here, we're gonna go. Oh, I might be doing this wrong. Okay. Oh no, I don't. I think this is good. Yeah. Okay. So for I know this looks a little bit scary. It's gonna be okay. For I in range length of list, so we start at the end of the list, and we're gonna go to position 1, and we're gonna go incrementally -1 each time. And we're going to use this helper function called bubble up. So for this one, for I in range 1 to the end is that I variable, and since it's going down, the first one, I is going to be the length of the list. Then the next one is going to be length of the list -1, or n-1. Then the next one, end is going to be n-2, and so forth and so forth. And it compares the two values right beside each other. If the one on the left is greater than the one on the right, switch them. So that's what this picture is kind of depicting. If 7, list at I-1, is greater than list at I, you want to switch them. And then once the biggest value is at the right side, then we call this function again, and I becomes length of list -1, because we're going in that reverse order. And we keep going up until that sorted part. So the sorted part is reversed now, it's on the right side. For this one, since we have like sorted and unsorted, it's again, like it doesn't have a worst or best case scenario. It's always going to be quadratic. So we start at the very side, I equals 4. So we're going to look from the left side all the way up to 4, position 4. So for here, compare 6 and 0, we switch them. Compare 6 and 7, yeah, it's very slow, and Obama does say not to use it, so I'd trust Obama. Switch 7 and 5, and then 7 and 1, and then 7 is now the sorted one. So remember, highlighted is the ones comparing. The blue ones are the ones that sorted. Now it's on the right side. And then white is not sorted. So once we go through this pass, we know 7's sorted. We subtract 1 from I, and we do it again. 0 compared to 6. 6 is bigger. 6 compared to 5, we switch those values because 6 is bigger than 5. 6 and 1, we switch those, and we don't even have to compare 6 to 7 because we know 7's sorted. Again, we go back to the start again, and I equals 2. So it goes up to and including wherever I is, and then it stops. It stops comparing them. Yeah. Yeah. Since they have the same time complexities, there are a lot better algorithms out there. These are the ones they introduce you with because they're a bit more simpler than the other ones. But yeah.
Yeah,
One over the other. Oh, sorry.
The just introducing you all to this stuff is more just to get you used to the idea of sorting algorithms. You would probably not be using bubble sort or selection sort in an actual implementation of a program because they're very slow.
Especially on big data sets. You'll learn more about big data and how it's used in companies. Because if you think about Google, I think they have like billions and billions of different data types and data just in general, like of gigabytes. So to do bubble sort or selection sort or even insertion sort, imagine doing a billion or trillions of different iterations. It would be very inefficient. But this is what we introduce you on because we want you to get used to calculating the time complexities of these functions. Yeah. Does that answer your question? Okay.
Yeah. And you'll learn about in A48, you'll learn about merge sort, which is a good sorting algorithm. And if you decided to take more CS courses, you'll learn about quick sort in B63. And that has like a similar average case complexity of n log n, so they're much faster.
Also in A48, you'll learn about BSTs, which are binary search trees, and they have a search algorithm or time complexity of log n. But yeah, you'll learn about that later. Don't worry about those now. For now, just worry about these three. These are the most important right now. And yeah, that's so it was only about an hour. But that's everything we have for you or prepared. If you guys have any questions, let us know. Um, doesn't even have to be about Python. Like if you're wondering about future courses, I know Alex has taken like B36, B63, B09. We've both taken B07, which is about Java, and A48. So yeah, let us know if you have any questions about the exam too. We've both done it and passed, so you know. Um, so for the final, I think a really good way to go through them is to go through each of the different worksheets that Anya goes through. That really helps you review the different concepts and try not to look at the answers again. Go through the different algorithms. If you can do it without looking at your previous answers, that'll really help. Yeah, and more stuff will be tested on material near the end of the term. So anything after the midterm would be more heavily, more heavily tested on. The reason why they do that is because the earlier elementary sort of concepts that you learned before with like lists and variables and what an integer is, those will be tested through lectures 9 and 12 anyways. So they just focus on a bit of the more harder concepts to go through. Because you know, like even with these different sorts, like you have to know what a list is. You need to know how to use for loops, or indexing, right? Or uh, for this one, you don't need splicing, but remember splicing. Yeah, so my recommendation for this course specifically is to go through the different worksheets, maybe working backwards, like work from week 12, week 11, week 10. Um, yeah, we can go over classes. I don't think you need to know
Are they being
too
tested
much.
on classes?
Only for unit testing is the only thing I can think of.
Yeah, I think in terms of unit testing, just know the syntax. But I guess if you want to go for classes, we can quickly. How to be
Yeah.
tested on unit test and reading and opening. You'll
Yes.
probably be tested on like just how to read and open a file. Know that. Know how to open a file. Know how to read from a file. For unit testing, know both syntax. So sometimes there's like two types of unit tests. There's one that tests modifications, and there's one that tests just changing variables. So you should know how to do both of those. The syntax is mostly the same though.
Got read. Oh no, semicolon. So yeah, remember you've got read, open, and write. R, O, and W. I think that's all of them. And append. And append, which is A. Oh, is it without the quotation marks? I think it is.
Oh, I don't actually remember. I'm used to writing in C where it has the quotation marks.
Okay.
Is it without the quotation marks?
Let me look. Let me look 1 second.
Yeah, I don't know, cause like it's because you pass it in as quotation marks, right? Because R would be a variable. Unless I'm wrong.
You do have to pass it with the quotation marks. Yeah.
Yeah, I thought so.
And if anybody wants the W3 schools, amazing. Love them. They're really good for like quick looking up of syntax and stuff. Not during an exam, but
Yeah, don't do that during your exam.
yeah, don't do that. Don't do that. But during studying, it's really useful. Yeah, so they have R, A, O, I think. Do they have O? I know they have read, open, or read, write, append. The default will be read. The default will be read because imagine you want to open a file and every time it's automatically open to write. Imagine how much data you would accidentally lose if you like just opened it to write all the time. Who knows the difference between write and append? Because that's something you could definitely be tested on. Mm-hmm. Yeah. Yeah, exactly. Yeah. So append will actually append it. So let's say the thing includes like these three sentences here, a message to display, blah, blah, blah. Just say that it's text. If you open it with A, it'll just append it to the end of this file. It'll keep adding it. Whereas if you open it with W, that will actually completely overwrite it and you will lose all that data. So yeah, you don't have to specify the R. I think
It
if you
depends
want,
how you
uh,
want to, it depends on how you want to use the file, correct? For what letter you include.
oh no, Alex, they're asking because R is default.
Oh, right, yeah.
I would say include it just in case, so that the markers know. But if you forget it and you just like leave it, it is the default. So I don't think you'll lose marks over it, but just to be safe, put R. Yeah. Oh, let me see if there's. Trying to think of anything else that we should go over. You have selection sort, insertion sort. These were the main topics, right? Like the time complexity and the different sorting algorithms. The final exam, I think it'll be. I'm not a TA for this course, so I can't
Did
specifically
Anya
mention
usually
that.
posts it on Piazza. I can't say for this semester, but I think last semester did she post on Piazza?
I think she did, yeah. Check Piazza, and also, yeah, check announcements just in case. It should be posted by now, though.
No, I don't think you'll have to define classes on the exam unless she added like it's the syllabus recently.
Let me look at the exam schedule for UTSC because that can tell you the timing. Um, it won't have like the details of it, but
I don't know, because it'd be very weird if they started covering classes in A08, unless I'm wrong. Because I don't remember, they didn't do it last semester.
and
And
they
I was,
didn't do it this semester before, and they didn't do it the semester before that.
yeah. So I think classes are just a thing for unit tests right now, so you can just treat it as a black box
Okay.
until later on when you actually learn what they are.
Okay, so you need the material. Here, I'll pause the recording because I think this is just kind of specific questions. Yeah. So let's. Okay, so the only thing that people missed on the recording is we defined this class. I learned that you guys aren't being taught by Anya and that you did learn classes. So this is just a really quick example on how to create a class, different variables. I don't know how in depth you guys went, so I'm just doing the basics. But basically, I created a class. I called it movie review. And it has three variables. We have the number of stars, so the default is 5. Name of customer who's giving the review, and comments, just random ones. So every class needs this. This is the starting function when you first define it. It's known by its name, underscore, underscore, init, underscore, underscore. Remember, self is always the first value that, or first variable that you want to pass through. That references this instance or this certain example of this class that you're looking at. And then it defines all the different values. So whatever you pass through, whenever you make a new movie review, you pass in those variables and they set them equal to that instance. So for this one, Katrina is going to have a rating of 4. Katrina, this was pretty good. For Alex, this is going to have a movie review of 1. Alex, this sucks. Okay, so these are going to be specific. And then we defined 3 more functions. These are just random. So change review doesn't return anything. It just resets the values. Print review, it does return something. It's not just printing. So returning a full string of all these strings just together. And then we also have is Katrina. It returns a Boolean. So from here, this is before any changes, we create them. So create example movie reviews. Before any changes, we print out the different ones. And actually, something we can do instead is we can just say print. I'm gonna print. Oh, this says your name. That's rude. How dare it just be your name? I know that's my fault, but customer plus. Yeah, okay. That's better. So here we can call this function. So let's say we want to print Katrina's print review. We don't pass anything through. And we're also going to print Alex's. So these would show the different values before we change anything. Okay. Alex, we now change this review. So this is a function we just defined. We have new stars, new name, new comments. We reassign it to this specific instance that we're looking at. So when we call it on alex.changeReview, only going to change Alex's values, not Katrina's values. And then we print Alex's review, which we can actually do. So in this case, I assigned it to a variable and then I printed it. And then we can print Katrina.printReview so that you can see that it didn't change Katrina's value. And then the last one is Katrina. It's just a, like, if it's Katrina, you return it. Alex got hacked because the review changed. So if we go through this, I'll show you a bit here. So Katrina's review. Oh, right. Not Katrina. We want to return self. I'm sorry, Alex. Okay, so Katrina's review is 4. Name is Katrina, and comments, this was pretty good. This is before any changes. And Alex's review is 1. Okay, this sucks. Then we change only Alex's review. And now it says Bob's review, because remember we're printing self.nameOfCustomer. The name is now Bob in comments, and then mine is still the same. And then for this Boolean function, we check, is Katrina? It's true. And is Alex Katrina? No, Alex is actually Bob because he got hacked. Does anybody have any questions? Or want to see another example? I can pull something out from my head. Yeah. Let me know if you guys want to see anything else. But other than that, we've actually it's almost the end of our review seminar. I hope this helps you guys.
Yeah.
I know your exam's in a little bit, but you guys are troopers and you're
Yeah.
coming early. So I'm proud of you guys. Yeah, no worries. Hey, best of luck on your exam. I'm rooting for you all.
Yeah. Yeah, I know it's not easy to take the course in winter when there's not as much people doing it with like a new professor.
Yeah. Oh, somebody just joined. Hi, Zora. The review seminar is actually just ending. We have like 10 minutes. I'll stay behind for any questions. Hi.
Yeah, I
But
guess
yeah,
I watch the recordings instead. Thank you.
you can ask any questions. We're just doing extra time now. Yeah.
Okay, let me take a look. What does this says?
So I will send right now we just did an example of a class.
Oh, great.
This is a movie review variables. I don't know how in depth I think his name's Kava, Professor Kava,
Yeah.
went. I've only TA'd and been in the course when it's Anya teaching, so I just did it like a quick class overview. Um, yeah, basically the initialization function,
Mhm.
setting it equal to like that specific instance, defined a couple functions, and then down here I actually like made an example of Alex and I. Yeah. We also like besides this,
Mhm.
we went through these slides. I can send them to you if you want.
Sure, that would be wonderful.
Yeah, we went through selection sort, insertion sort, and bubble sort, which are really important for your exam. Let me send them in the chat. We also went through time complexity, the differences between constant, linear, and quadratic, and polynomial you don't really have to worry about. And we also went through unit testing. So the different types of functions that you can have, like returning values, making a whole new one, or mutating a list already.
Mhm.
And then how to test those. And that's how we kind of got on the topic of classes. And then one of you guys told us that you actually do learn about classes, which is different from what I learned in Python. So I did that quick example.
Mhm.
Yeah. Oh, yes, and we also went through the entire example of generating a new story, which Alex went through, which was really nice.
I was wondering, where would you post the recordings, Zoom recordings for this?
So I'm going to post it on Amax's Discord server. Do you have Discord?
Yeah, sure. I think I just joined the community. It's called AMACSS community.
Yes, yes. The Python file for the classes example. Sure. Yeah, I can send this. Yeah, I can let me
Thank you,
upload it to
Katrina.
my Google Cloud or my Google Drive, and then I will upload it in this chat as well as in another thing too. Yeah.
No worries. You can actually send it afterwards.
Okay. Yeah. Let me know. Do you guys want me to do another class review or like? Do you have any questions about classes?
Actually, I'm not that familiar with classes.
That's okay. Yeah, if we want, I can go through another example. Let me just put how do we do, I think this is, yeah, this is several comments in Python. Okay, so say winter 2022 CSCA08 final review somewhere, just so that everybody remembers. Okay, so this is an example of movie review, and then below we will do another example. Alex, any suggestions for what to make a class out of?
Oh, let me think. There's one from VO7 that was kind of cool, but I don't remember what it was.
Okay.
How about making like, did they cover inheritance yet or no?
No, don't mention that.
Okay.
Ignore what Alex just said. That's not important for this right now.
Yeah, okay. They just have classes.
Oh, what about an animal or
Oh yeah, that's I was
yeah.
gonna say something like that.
Okay, so we're gonna do an animal class. Azora, Davian, and Rand, what is your favorite animal?
Rabbit.
Rabbit. Okay, so we're gonna do a rabbit class example. Okay, so first things first, to define a class, you literally type the keyword class and you name it. I'm gonna call it rabbit. What features what features does a rabbit have?
Quiet.
Okay,
Clever.
so
Clever.
personality is quiet. Oh, actually, you know what? This is a great example. We can do it as a list. Yes. This is where things go wrong. But yes, okay, so we have quiet, we have fast, has long ears. Yep, I'm loving this. Okay. What else is I don't know, they like carrots. Okay. So you have personality. So that's now a variable inside of rabbit. Okay. We'll get to some examples later. So we have personality. Let's say age. It starts at, let's say 0. Right? That's how rabbits work. And what's another data type? We want strings and maybe a dictionary. So a string, the name of the rabbit. Yeah, let's name it Peter. What's that rabbit's name? In Peter some. What's a common rabbit's name? Floppy. So the default name is Floppy. Peter Rabbit. Okay, so it is Peter Rabbit. Thank you. Default name is Peter Rabbit, and last but not least, oh, I love that. Okay, oh, that's so cute. Last but not least, what's a good dictionary example, Alex, for a bunny? Or rabbit?
Bunny, rabbits, hare.
Ah, friends. Maybe. I don't know. Do you have a better example?
Oh, for rabbits, let me think. Peter Rabbit, there's Bugs Bunny.
Bob is yeah, let's say that for each of the friends, we have a dictionary of the names and we'll have their age. So Bob is 2. Alex, how old do you want to be?
I want to be 2 years old.
Okay, Alex is also 2. Azora, you can be 4. Davian, you're also a friend of whatever this rabbit is. You're going to be 3. And Ran is going to be 7. You can be the old wise one. I will also be in here. And I'll be 1 because I'm a child. Okay. Now, we're going to define the initialization class. That is always important for each class that you make. So first we define it, so DEF for function, underscore, underscore, init, underscore, underscore. This is a specific function that when you first create a rabbit class or like a rabbit instance, it'll call this function. So the first variable that you have to put in is self. That refers to that specific example or specific instance or specific object. Those all mean the same thing. That specific example of that rabbit, that's when you call self. And then we need to pass through all of these because these are just defaults. So we need to pass through personality, age, name, and friends. Okay. So to initialize all of these values with this specific instance, we do self.personality equals personality. Yeah, I think that's how you do it. Age or self.age equals age. Name.age. You can overwrite strings, can't you, Alex?
Um,
You have to do string copy.
oh, in Python, no, I think you can good point. They are immutable, but I think you can overwrite the variables. Like you can change the variables. I just think you can't like modify a string. I think you can. I think you should be able to just assign them like that.
Yeah, because that's Python, or that's C. Okay. And then friends, self.friends equals whatever you set it equal to. Okay, so this is a really important function that you have to have in a class because this is the initialization function. Okay. Yeah, let's make an example. So, examples of rabbit instances slash objects slash what's it called? Instances, examples. So I want to be a rabbit. So my name's Katrina. And to create a new rabbit, you just call the class and you pass through each of these variables. So for personality, remember you have to pass through a list. So I'm sleepy a lot of the time. I like food. And yeah, that's it. That's just me. My age is going to be, yeah, let's say I'm 1. Name is Katrina. And friends is a dictionary. So I'll pass, I'm not going to type them all out, but Alex, you're my friend. And you are 2. I think that's it. Yeah. Okay. So this is how you create an instance of a rabbit. You pass through the different parameters. You don't have to pass through self because that's like the actual function here. The self is, I don't know how to explain self. Self is just, it's the instance already. You don't have to pass it through. Okay, and let's say we want to print it. So let's make a function to print. Let's say print rabbit. Yeah, okay. And we don't have to pass anything in, and it'll just print it. So it'll say personality. And we want to loop through and print each of those. So for trait and personality, so we're looping over this personality. We're going to print out the trait plus a comma and a space. Is this making sense? We're going to print it out and we're going to get to the end. After we print all the personalities out, then we're going to print age. So age is going to be, since age is an integer, we need to convert it to a string. We say self.age. That's how we reference different, this should be self.personality as well. That's how you reference these variables up here that are attributed or that are attached to the Katrina rabbit or to the Azora rabbit, to each instance or example of the rabbits. So we print the age, then we can print the name. Are you getting the hang of this, hopefully? And then we want to print all of the different friends' age as well. So we'll say friends. And for this, we're going to print through, how are we going to do this?
Would you have a nested for loop through friends? Through like the friends list?
Nested for loop?
Yeah, so you just have another for loop within the traits.
But then we'll have like several ages for each one.
Oh, that's true. Sorry.
No, it's okay. So let's say we want to make two lists. So we want names equals self.friends.keys. That's a function, pretty sure. And then ages equals self.friends.values.
Yeah, we covered that earlier.
Yeah. And then we do one for loop and we say for name in names. Oh, geez. Okay. We want to print out name of friend. Or maybe I should do the index. Range, length of names, because they should be the same length. Let me know if this is confusing anybody. I'm sorry if it is. Plus age. Oh, dang, I went across it. No. There we go. Is this making sense? Azora, Davian, Ran, you good? You still with me, please?
Yeah, makes sense for me. It's clear.
Okay. Awesome. Okay, yeah. I'm just trying to print out all the names and then I'm getting a list of all the keys and the list of all the values, which are the names and ages. And I'm printing it out. Okay. Now we can actually call this. We're not returning anything, so this is just printing it. So we do Katrina dot, this is how we call a function on it, print rabbit. Oh yeah, no worries. This is a good recap for me for Python, and it's good practice. Plus I want to help you guys. So let's say we want to, something went wrong. What went how? Debugging in its finest.
The keys object is not, oh, you're trying to, yeah, it's like it's a list of keys. It's not subscriptable.
Should be a list.
Names, yeah, it should be a list of the keys.
Keys. Just double checking what it returns. So when you do keys, returns a view object, contains the keys. Let me see what it looks like. Print X. Dict keys object. How do we convert that? So trying to think of how to go through this. Okay, another way we could do it is I equals 0. We can change this to be each of the names instead. So for name and names, and then we just add one each time. I don't know if Python has this, so I'm going to do I equals I plus 1. So then we just print out the name.
Hopefully this works.
It should work. Yeah. No, it should not. Why?
Not something about dict values object not being subscriptable. It should be though, because it's a list. Why is it not subscriptable?
I don't know. Let's maybe it's something with this. Oh, am I back?
Not subscriptable. Why? Yeah, it should
Maybe
work. but-
ages is also one.
Self.friends. Does I have to be in the for loop? It shouldn't have to be.
It doesn't have to be. I know it. Okay, hold on. I've got this. So we have this. All we do is we just convert it to a list. You gotta love key types. Range length of names. And then names at position I and ages at position I, and I'm going to put this to a new line because it will complain and we don't need I. Okay. Does this make sense? So I'll explain. Basically, if you don't convert it to a list, it's something called a dict values and dict keys, and those are like dictionaries. So you want to convert it to a list. Please work. Okay, ages. Okay, so I know the error, but I want you guys to help me out. Why are we getting this error? It's a type error. Can only concatenate string, not int, to string. It's on line 78. What seems to be the problem? Alex, stop smiling. I know you know too. Exactly. Yeah. Age needs to be a string. Perfect. Now this should work. Yes. Okay. So ignore, I'm going to comment all of this out just because this is from the previous example and it'll look weird with the print statements. So if we run this again, as you can see, the first one is personality. So we get sleepy. I'm actually going to get rid of this thing. So we get sleepy, likes food. We get age, 1. And this is specific to what I put here. So this is important. This is only for Katrina Rabbit, okay? Let's do another example. So Azora, let's say you want to be a rabbit, because they don't have exams. Let's say you're fast, you're quick, hopefully you like food.
Yeah, yeah, me too.
Yeah. Let's say you're, what are you? You're 4 years old. Your name's Azora, and you have lots of friends. Your friends are all of these people. I'm just going to copy this. So basically what this would do is it would add, and we would close this off there. So this is all one dictionary, sorry. So like this is a dictionary. And these are all the friends. So we're passing this through to the rabbit class. We're creating a new class. We've got the list of personality, the age, the name, and the friends. And if we wanted to print out, we could say azora.print rabbit. Fingers crossed this works. And now we can see, so this is my friend, and then we get to the personality again. So you're fast, you're quick, you like food, your age is 4, name is Azora, and these are all your friends. Is that making sense?
Yeah, it makes sense. Wow, I have so many friends. I'm so happy. At the end of December, I make so many friends.
Well, hey, you can always text me on Discord or something. So we're always here for you. But yeah, so you can tell these are two separate instances or examples or objects, whatever word you want to use. Like Katrina is one rabbit, Azora is another rabbit. If I created an Alex rabbit, that would be separate. If I changed Azora's rabbit, like if we wrote another function and we said define change rabbit, and then we reset all of these different variables, that would only change Azora's rabbit, not Katrina's, not Alex's, not Davian's, none of the other object instances, only that one that we're changing. Does that make sense?
So it's independent from other functions?
Right, it's independent from other examples. So this is one example, this is another example. Yeah, let's say for the sake of it, we want to create a Davian rabbit. Let's say, just to change it up a little bit, quick, likes food, you are 2, Davian, and let's do this. There we go. Okay, so just to change it up a bit, we can print it out. And now we're going to add a function that actually changes it. We can do this quickly because I know I don't want to take up a lot of your precious student time because I know a lot of people have exams. But I'll go quickly. So change rabbit, we're defining a new function. This is going to have more parameters. So we're going to do personality. I think it's age next, name, and friends. These are the new ones. So I'm gonna rename them. New personality, new underscore age, new name, new friends. So from here, if we want to change the ones of the specific instance, we do self dot personality equals new personality. Self dot new, or not new age, self dot age equals new age. Self dot name equals new name. Last but not least, self dot friends equals new friends. And this would overwrite whatever data we already had. So we've printed them all out before we change anything. Let's say we wanted to change Katrina rabbit instance. So this is now a function of the rabbit class. So we can call it on any rabbit. Katrina, Azora, Davian, any of these. So let's say Katrina.change rabbit. Yeah, so I want to change my personality. I'm now only likes noodles. Yeah. I'm now also 0 years old now. My name is no longer Katrina, it's Bob. And I have 0 friends. Why not? It's myself. I can be, yeah, never mind. So now that we've changed this, why is it complaining? Oh, I didn't finish the the list. Okay, now that we've changed this, let's try printing it out again. Print rabbit. And if we do it for all of them, only mine should be changed. So if you run this, I know there's going to be a lot of print statements. Okay, so this first one, this is mine before being changed. Second one, this is Azora's before being changed. But since yours didn't change, it shouldn't change.
Mhm.
Third one, this is Davian's rabbit. And then, if we look again, this is now mine after I changed it. I only like noodles. My age is 0. My name is now somehow Bob, and I have no friends. But when we print out Azora's rabbit, you still have the same things that were attributed to your instance of the rabbit.
Mhm.
So just because we changed mine doesn't mean it changes all the rabbits.
Mhm. Yeah, it makes sense to me.
Yeah?
Good. Yeah.
Good.
Such wonderful
Okay.
examples.
Yeah, okay. That's good. Is there any other examples you want to see? Like a return function? Like a function that returns something from here? Because all of these, they just do stuff. They don't actually return anything.
I guess I'm good. Let's take a look at others in the chat. Oh, they haven't said anything.
Yeah, I'm kind of looking. I can do one more, and then I'll ask any questions, because I know we're getting a bit late.
Guess I'm gonna head out now, everyone, because I'm a little tired right now and I need a coffee. So thanks for,
Get
for
coffee.
everyone.
Thank you,
Thanks.
Alex.
Thanks everyone for coming out. Thanks for Katrina for doing all these examples, and I hope everyone has a great time in the exam. So I'll see you all later.
Good luck on your exams, Alex.
Yeah, you too. Bye.
Okay, yeah, I'll do this one more. So let's say we want to, what do we want to return? Let's say we want to get the age of all of our friends. So instead of printing the rabbits, we just want to get ages of friends. Okay, so we're not actually going to pass anything through, but let's create a list. So ages of friends, make it equal a new list. Then we're going to go through each of the ones. We're basically going to do what we did right here. So for I in range length of self dot friends. Yeah, I think we need to make this. We need to get the keys, so all the names, and get the values, and we can say it's the length of the names because they should be the same. And then we want to append it, ages of friends dot append names at position, or actually not names. We want to add ages. Actually, I think we could just go through the ages then. So we don't actually need the names. We would do for age in ages. And we would append age. Yeah. And then we return it. Ages of friends. So just to kind of explain it again, made a new list. Made a new list. Got list of all friends. Oh, wait, I just realized this is really dumb. We don't need to make a new list. I'm sorry. We could just, yeah, I'm sorry. Yeah, okay, so we don't even have to make a new one. All we're gonna do, get rid of this. Get rid of this. Just gonna return this. We're gonna get all the values. So self.friends. Friends is the dictionary for this one. Thanks, Azora. You get the friends, you get the values, and then you convert it to a list, and then you return it. And so when we call this function, this is afterwards. So let's say, Azora, you've got the most friends. Azora friends equals Azora. So Azora is the rabbit, dot get ages of friends. So we're calling that function. We don't have to pass anything through. And now we have a list. So for friend in Azora friends, print friend. And we should see all of Azora's friends. Right, these are the values. Yes. So you get the ages of all your friends. But does that make sense? If it's returning, you need to set it equal to something or print it, or you need to get the value somehow and set it equal to a variable that you can access outside of the function. Otherwise, it won't do anything. Whereas like Katrina.printRabbit, that will just execute whatever's in here. And since this already prints and it doesn't return anything, you don't have to set it equal to anything.
Thank you, Katrina. It makes sense.
You're welcome. Yeah, I hope this helps.
It helped me a lot.
I will, I'll upload this to, I'll upload it to my Google Drive and then I will share it on, let me pull this up first. And then I can do it now in here so that you guys have it. And then I will also upload it, like I'll put it on the slides, a link to it, and it should be unlimited, so. Okay, let me know if you can access this.
Yes, I can get access to it.
Okay, awesome. And below here, class examples. There you go. If you guys forget it, it's also in the review seminar. So, yeah. Okay, let me know if you have any questions. Otherwise, I think that will be everything. Yeah.
Katrina, thank you so much.
No worries. Okay, well, I hope you guys have a great time, like a great rest of yours. More material in A48. A48 goes a lot more in time complexity. It's in a lower level language, which means that it doesn't even have strings, doesn't have a data type. Inheritance is not covered in A48, to my knowledge. It's covered in B07, which is a second year course. It's really fun, though. Recursion is a taboo word until the end of C, or until the end of A48. It's definitely covered in there. Yeah. It's a lot of fun. I actually just did a review seminar on it, and it was, yeah, you learn a lot about BSTs and graphs and linked lists and how to use recursion with each of those. It's very fun. But you don't have to worry about that for A08. A08, at most, remember classes, sorting algorithms, time complexities will be quite simple. Linear, quadratic, or constant, maybe polynomial. And yeah. In A48, read the notes. If you're taking it with Paco, read the notes. There are 6 units and they're very long, but read them because they will be on the exam, and they are, yeah, they're definitely worth it. Read the exam or read the notes before you go to class. That's what I would say, and practice the exercises. So the exercises would be like extra questions, and you can ask Paco about the answers in class, but definitely practice, I'd say. Make sure you understand the concept solidly, because there'll be some crunchy questions. In A48, for me, it's the graphs. That's at the very end. There's something called a DFS and a BFS, I think. They're different. So like, imagine you have like a whole grid of different numbers, and you're calculating the time complexity of it to find or to go through all the different nodes. There's different edges, there's different nodes, and then to calculate all the different, I guess, amount of edges and nodes there are, and then to be able to search through each of those. There's like directed and undirected graphs where, let's say I'm friends with Davian, but Davian's not friends with me. That would be a directed graph. Whereas if we're both mutually friends, that would be an undirected graph. Yeah, I think for me personally, that's what the hardest one was. BSTs is a really big concept that they cover. But once you understand what a BST is, a binary search tree, it makes a lot of sense. Yeah, that was the hardest part. Biggest leap in complexity. I would say C is, or A48 is quite a bit harder than A08, in my own personal opinion. Because instead of having like strings, like you have in Python, you have an array of characters, like single letters. So it's not, what's it called? Like when they say low level language, it means that you have to define more things as you go along, but you can usually do more things. C also doesn't tell you about different problems, like the specific problems. You know how we were in Wing 101 and it let you know you used an integer instead of a string. C doesn't do that for a lot of different problems, so you have to figure out what the problem is based on logic and knowledge. You go a bit more into time complexities, yeah. Linked lists are like the introduction to BSTs. So, oh yeah, one of the big concepts in A48 that's different is pointers. Pointers is where you get a lot more into memory and how data is stored in memory in C. So on the actual computer, there are different memory addresses, and you put the data inside this box, and it gives you the, it's like a random number in memory, has the name of it, the data type, and then what's actually in there. And yeah, there's a lot. A48, it's a really fun course. I definitely enjoyed it, but I do know it's hard. But you guys are well on your way to it. I'm pretty sure you guys will be great. Yeah. Are you taking it in the summer? Oh, you are taking it. Okay. Let me see if I can. E48. I'm gonna stop the recording because this is